Friends, and welcome back. So in this session we are going to cover a very important area which is called the garbage collection, sometime also referred as only the GC. Okay, so this garbage collection is related with your heap size. Okay, there is a relation with the heap size. Okay, and there is a great importance of garbage collection in the tuning of the heap size as well. Okay, so it is very important to understand what exactly is the garbage collection, how it works, what are the basic concepts, how it help us to better tune the heap size. Okay, so this I am going to cover in this section completely theoretically, where I will give you the overview of what is garbage collection, what is the importance of garbage collection, okay, and how to enable the garbage collection logs. Okay, that we will see in the execution as well in the next section. Okay, but in this particular session I am going to cover the complete end-to-end details of the garbage collection. Okay, so that you will have a complete end-to-end clarity, right? So now before we go for the garbage collection, let me recap one of the basic concept that we have learned in the heap, specifically the heap memory architecture. Okay, because it is very important to understand this heap memory architecture, and then you will have a complete clarity on the garbage collection, how it works internally. Okay, so what we learn about the heap structure or heap architecture in one of the previous session is we have two sections in the heap. Okay, the first section is called the young generation and second is called the old generation. So these are the two important part of your heap size. Okay, so till Java 7 we had one more section which was called the permanent generation for the metadata of the classes. Okay, so this is not now part, it is not part of the heap size. Okay, from 8 onwards. So till Java 7, if you are using Java 7, okay, so till Java 7 the permanent generation was there. So for that there is a parameter called hyphen x perm gen to define the value memory heap size. Okay, so this parameter is not applicable now from Java 8 onwards. Okay, so now that means we have two main areas which is called the old generation and called the young generation. We have two these partitions now made. Okay, so now what happened, uh, from 8 onwards, as I said, this permanent generation has been replaced with the meta space, which is the external memory, native memory. That means this permanent generation was part of the heap till Java 7. But now this permanent generation has been replaced with the meta space, and this meta space is allocated in the native memory. Native memory means it's not in the heap, it is outside the heap. For example, if you have a RAM of your system is 16 GB, okay, your heap size is 4 GB. Okay, so for this meta space you can define some separate space. For example, 512 MB you define for your meta space. So what will happen, this 4 GB specifically will be for your heap size. For meta size, this 512 will be taken from your RAM, not from the heap. This is the difference between permanent generation and the meta space now. Okay, so now Java 8 and beyond the heap consists of two main parts, young generation and the old generation. So as I said, we have a two important part in the heap size. One is the young generation and second is the old generation. Okay, and this garbage collection is completely based on how the objects are moved between your young generation and the old generation in the heap size. Now, what are the objects? I will explain everything with detail. Okay, but before that, let us see now what is garbage collection. So, garbage collection is a JVM process that automatically identify and remove unused object from memory to free up heap space. Okay, so now what we have learned about the heap. Okay, this heap, suppose that this is a heap. Okay, this is a small portion of the memory that we take from the RAM of your system. Now suppose that I have an OS which is having the 16 GB of RAM. This is my RAM. This is one of my server. This is one of my WebSphere server with the name of server underscore 1. So I have defined 4 GB for heap for this particular server. So when you start the server, okay, a JVM is initialized. You can see that with the help of process command at the OS level, and then 4 GB depend on if you have defined the minimum XMS and XMX, both same 4 GB. So this 4 GB will be allocated as soon as your server is started. So now what is the free memory available in your system OS level? 2 GB, right? Because the 4 GB has been allocated to your JVM for this particular server. Okay, so now what happens when your application start executing the request? There are a lot of business logic which is getting executed. There are a lot of requests which is coming from the browser. Client are accessing the application, and this particular server is processing the request. So when this particular server is processing the request, okay, so multiple data, okay, stored in your heap during the processing. Okay, and one of the critical data is of the objects. Okay, so that means simple, you can say when your server is processing the request, there are multiple objects are getting created inside your heap size. Okay, so multiple requests are coming to your server, some of them getting executed successfully, right? Some of them may be running for a bit longer time, but after that they will be complete. That means the requests are coming to your server, they are getting completed, and then new requests are coming to your server, right? This is the normal process. So what will happen when the request is coming, it is getting processed inside your heap size, objects are getting created here, and when the request is complete, so whatever the data or the objects created by this particular request inside the heap, it has to be cleaned, it has to be thrown out from the JVM heap, right? Otherwise what will happen, your heap size will get exhausted. If the objects are created by the request during the processing, which is not going through, which is not throwing out from your heap size when the request is completed, so your heap size will get full, right? The other new request will not get the space for the execution. So this is a very normal process. Whenever the request execute, it create the object inside your heap. As soon as the request is completed, the object that is refers by this particular request, which is now completed, will be thrown out from the heap size so that other new requests can process. Okay, this is a very simple process. Now you may get confused, what is the object? But I'm saying that there, whenever a request is coming, there are a lot of objects are created inside your heap size. When the request is completed, then the objects get thrown out from the heap size. So what exactly are the objects when we say the objects are getting created inside the heap size? Okay, so very simple. If you have idea of any of the programming language, doesn't matter Java, if C, C++, Java, any language that you know, okay. So how we define the different variables? Now suppose that I have defined a string variable, okay, and this string variable has the value as name. Okay, so I have given the name for this variable. Now what is the value inside this variable? The value is digitalk. So this is a string value. So that means I have created one variable and I am storing a value inside this particular variable in my code. Okay, so this is a variable with the name, and the value which I am storing inside this particular variable, or this is a data, right? A specific data which I am storing inside a variable. This is called the object. Simple. So similarly, I have a big code where I have defined multiple variables inside my code, and there are multiple values are there for each and every variable. So that means all these are creating inside your heap size. Okay, completed. This object is need to be cleaned from the heap size. So very simple, very straightforward process. Whenever we have a heap size, my applications getting the request from the clients, it is getting executed inside your heap size. That means multiple objects are getting created here by the each request. When the request is successfully completed, this particular object that was created inside the heap, it has to be thrown out from the heap so that other new requests can process. Very simple, right? Now what is garbage collection? This is the work of garbage collection. Garbage collection is a process which run automatically. Okay, you can run it manually as well. I will tell you how to do that. So basically it runs internally, okay, and automatically. And what is the work of this garbage collection? It to automatically remove the unused object from the memory. Simple. Whatever the things we have discussed so far, that heap need to be cleaned. That means all the dead objects. Why I am saying dead object? Because if the request is completed, the object which is inside your heap will refer as a dead object, right? Because the corresponding request is completed. So now this object is dead. So we need to throw it out from the heap side. Okay. So garbage collection is the process which look for all these dead objects, whatever being not referenced by any request, because that particular request is completed. Okay, it will be cleaned or thrown out from the heap size so that the heap will be sufficient for the other new request. This is the work of garbage collection, and the name is very clear, garbage, right? You have to clean the garbage, so it is doing the cleaning of the garbage from the heap size. And what is the cleaning? To remove the dead objects from the heap size so that sufficient memory should be available always for the new request. Okay, this is the garbage collection. Now hope it is clear to you what is the garbage collection and what is the purpose of garbage collection, right? Now let us move next. So as we know that we have two different sections of the heap size, what we have learned, permanent generation is not there from 8 onwards. So old generation and young generation. Okay, so if this young generation has again three parts, Eden and survivor. In survivor we have two, S0 and S1. Okay, so now simple, heap size has two partitions, old generation, young generation. This young generation has three partitions, Eden and Survivor. And Survivor we have two parts, S0 and S1. So what happened? Whenever the new objects are getting created, for example, this is your heap size. Okay, the requests are coming from the client, like this one. It's all are getting processed by your heap size, right? The objects are getting created here. So whenever a new request connected to your heap size, so as I said, in heap size we have two partition, young generation and old generation. This young generation has three part, Eden, S0 and S1, right? So what happened? Whenever a new request coming to your WebSphere and getting executed by your JVM, okay, so this is the first area where new objects are initially allocated. So that means first it will connect to the young generation part. Request will connect to the young generation part. And inside young generation, we have three, Eden, S0 and S1. These are the three parties, right? So what will happen in that case? Objects are first created in the Eden space. Like suppose that there's a client connected, okay, and the request need to be executed inside the heap. So the new request will first connect to the Eden here. So all the objects that is created by this particular request, for example, this is a request 1. Okay, so for this, all the objects will be created in the Eden space. Now, when the Eden space has become full, a minor garbage collection is triggered. So now suppose that there is a specific size of that, right? My heap size is 4 GB. 4 GB. Okay, out of 4 GB, there is some size internally allocated for the old generation. There is some size allocated for the young generation. And whatever the size that is there in the young generation, it is allocated to the three part, right? So that means it will get full after some time because all the new requests are first connecting here, right? So when this Eden space is full, so what happens? There is a minor garbage collection is triggered. Now we have learned about the garbage collection. So inside garbage collection, we have a two type of garbage collection: minor GC and major GC. I will explain you what is the difference between minor GC and major GC. Okay. So now suppose that when the requests are connecting here very firstly in the Eden, if it is full, a minor garbage collection will be triggered, and this is a stop the world event, meaning all application threads pause briefly. Now this is a very important part. This is a stop the world event, meaning all application thread pause briefly. So what happens whenever the garbage collection is executed, which is going to clean your heap size, during that time your complete heap size is blocked. This is completely blocked. That means no request will be processed by your heap size till your garbage collection is running. And that's why it is very important the time that has been taken by your garbage collection to clean your heap size should be very minimal. Okay, it should be in milliseconds, okay, or sometime maybe between 1 to 3 seconds. Okay, why? Because during this time frame the request will be not processed. All the requests which is there inside the heap will be stopped. That's why it is called stop the world event. Okay, and that's why most of the time this garbage collection executed in a millisecond of a time, so that the request will not get hampered. Okay, or sometime when we have a problem, it may take 1 to 3 seconds or more than 3 seconds as well. So now suppose if your garbage collection, the process which is clean the heap size is taking more than 3 seconds, so your application will get paused for that duration, 3 or 4 seconds, right? So there would be intermittent behavior in the applications, the users, right? So this is the important point. So what will happen during this process? Unreferenced garbage objects are removed and the surviving objects are moved to survivor 0. So what will happen when the Eden is full? Okay, so a minor garbage collection will be initiated. So if there are any dead objects like which is not referenced by any request, it will be removed from the Eden space. And if some requests are there which is actually referenced by some request and which is processed, it will move to the survivor S0 space here. Okay, so now what will happen in the next GC cycle? Surviving objects from Eden and S0 are moved to S1. Now suppose that this is also full, right? So again there is a garbage collection will be executed, which is a minor garbage collection. Okay, and what will happen if this is getting full? So all the dead objects will be removed from here, and if any object is there which is still referenced by some request, it will move to the S1, like this one, S1. Simple here. So this swapping continue between S0 and S1. So what will happen? This swapping will continue. Requests are from Eden coming to S0, and from S0 it is coming to S1. And objects that survive multiple cycles are eventually promoted to the old generation. Now this comes a other important part. If the objects which is reference here Eden is full, it is moved to S0. Still it is referenced by some request, move to S1. Now what if S1 is full? So once the S1 is full, that means your young generation last partition is full. Now this will move to the old generation here. The objects will move to the old generation at the last stage. Okay, and this is the second part of your heap, right? First part is the young generation, second is the old generation. So now here what will happen? It will move to the old generation. Okay, so now what is happening here? We know that in the first part we have seen there is a minor garbage collection is executing, right? And when the request is moved to the old generation, so there would be some time your old generation space may also get full, right? So once your old generation space also get full, so there has to be a GC to be executed in the old generation as well, right? And this is called the major garbage collection. Now let us talk about this one. The old generation hold objects that have survived several GC cycles are considered long-lived. When the space fill, a major or full garbage collection is triggered, which is more expensive in terms of time and resources. Okay, so in the young generation, objects are moved from Eden to S0, from S0 to S1, and then it moved to the old generation. So in the young generation, when this Eden is full, when the S0 is full, when the S1 is full, there is a minor GC is executing. So minor GC means which is going to take very fraction of millisecond of a time, which will be very small. Okay, and then when the objects are moved to old generation, this old generation, okay, which is having the big size in comparison with the Eden S0 and S1. For example, 4 GB is the total size of your heap. Okay, there could be possible that this old generation may have 2 GB of size out of this 4 GB, and this Eden S0 and S1 will be divided in the remaining 2 GB, some fraction of that. Okay, so now that this older generation has a big size in comparison with the Eden and Survivor in the young generation, right? So when this old generation is full, then again a GC will get triggered, and this trigger will called major GC. Major GC. So that means minor GC is occurring in your young generation, major GC is occurring in your old generation. So this is very expensive. Why is this expensive? Because old generation size is big, and as much the size of the heap is big, the clean will also going to take a bit longer time. So here Eden Survivor has a less size, so the GC is minor because it is going to take less fraction of seconds. It will execute very short time. But if it is happening GC is happening old generation, then this is a major GC which will take bit longer time. It could be somewhere around 1 to 3 seconds. Okay, and now what is the other consideration, important consideration here? If I am saying that old generation is also getting full and major GC is executing, that means your complete heap size is almost getting exhausted, right? Because Eden is full, S0 is full, S1 is full, and that's why the objects are moved to old generation. And now old generation is also going to be full, and I need to run the major GC. So that means your complete heap size is getting exhausted. So major GC will mostly occur when your complete heap size is full, occupied, right? So that's why when we monitor the log files of the GC, if we are seeing that major GC is occurring multiple times and very frequently, right, that means your heap size may be short. That's why the major GC is occurring so frequently, right? Because if major GC is occurring frequently, it's an indication that your full memory or full heap size is getting exhausted very frequently, right? So this is a very important consideration, and why that's why the reason I explained you in detail about the memory structure, young generation, old generation, how the objects are moved from one location to different location, what is minor GC, what is major GC, and what is the symptom it is indicating if the major GC is frequently occurring in your system, and why this time important, whatever the time that GC take, because this is a stop to the world. Simple, your application will get paused. If your GC is taking 5 seconds, it's a big problem, because for 5 seconds your application is going to be halt. And we have a multiple applications where we have a SLA time or response time of hardly 1 second, 2 seconds, or multiple time less than 1 second as well. And if it is a garbage collection is occurring for 5 seconds and even for 3 seconds, so application are going to be paused for that duration. This will be a SLA breach for you. So that's why it is very important to tune the heap size and according to that we have to tune the garbage collection as well, so that your pause time should be very less. So when we do the tuning of garbage collection, so what tuning we are doing, we have to work to minimize this pause time. If my garbage collection is taking 3 seconds for the full garbage collection, it I should minimize it to 1 second, or at least 2 seconds. I have to minimize that one. This is the overall goal of the garbage collection tuning. So now you have a complete end-to-end picture of garbage collection. So what is GC? It is an automatic process by the JVM that frees memory by removing the objects no longer in use, or you can say dead objects from the heap size. Why GC? Java manages memory automatically, so developer don't have to manually free unused object, avoiding the memory leak and crashes. Right? Okay. So now this is completely and automatically process. So developer don't need to worry about defining any specific code for deallocating the objects which is not referenced by any request in the JVM heap size. So this is an automatic process. How does GC work? JVM track object references. Object no longer reachable are considered garbage. GC identify that unreachable object and reclaim their memory. So now, because it is an automatic process, so JVM continuously monitor your heap size, and it always look for the object which is dead or not reachable. And if it find any object which is dead or not reachable, it considered it as a garbage. Okay, and then it remove it from the memory. So we have a two type of garbage, minor GC and major GC. Now you have a clear that minor GC occurred in the young generation and major GC is occurred in the old generation, and which is very expensive, right? GC impact, as I said, pause application thread during collections can be short or long depend on GC type. So the impact is the pause, it depend on, if the pause is very long, then application is going to be halt for a longer duration. If it is short, then there would be a good performance of available application. So what is our goal? We to minimize pause time, which effectively freeing the memory. That means whatever the time that is garbage collection is taking, our purpose is to minimize that time which is taken by the garbage collection. Okay, when we do tuning, so JVM offer flags to configure GC behavior. So that means whenever we tune the JVM, okay, now depend on which JVM we are using. Okay, there are a lot of JVM vendors from Oracle. There is a open source JVM. There is some OpenJ or OpenJ logs Java from the IBM. So depend on which vendor you are using. Based on the vendor, you may have some different Java flags. Okay, so like the standard we have for memory XMS and XMX to define the minimum and maximum heap size. Similarly, we have a multiple parameters that we can define for the JVM for different purpose. Okay, so when we tune the JVM, okay, so we have a different garbage collection algorithms as well, right? Because GC is an algorithm, okay, which clean your heap. So we have a multiple algorithms. Okay, so out of all the existing GC algorithm, we may have to select any one of them which is best for our applications. Okay, so this is called the tuning of the garbage collection. And why GC is important? Because prevent memory exhaustion by reclaiming unused object, right? So every time it is cleaning the unused object from the heap size, so that means it is cleaning your heap and making sure that sufficient memory is available for the new request. So this improves the stability of app servers, right? Because always you will have a sufficient heap size will be available for new request. So it is a stability of your application server, reduce out of memory error risk. So suppose that whenever your heap size is getting full and it is not getting clean properly, okay, so we get a out of memory risk, out of memory problems. So this garbage collection reduce the out of memory problems and maintain performance when tuned properly. So if you tune properly, then your garbage collection is taking very less time, then definitely the performance of your application will be increased. So if your GC is poorly tuned, what will happen? Frequent GC pauses. There would be a frequent GC pauses, and if frequent GC pauses are there, your application is definitely going to be slow. If long full GC pauses are there, again user feel hanging slowness. If the GC is taking 3 seconds, 4 seconds, 5 seconds or more than that, definitely it is a problem. And then you will have a memory leak symptom. Keep growing. So memory leak means the objects are getting created in your heap, okay, but it is not getting clean. Your GC running, but it's not able to clean the object from the heap. Okay, or maybe the objects are getting created so frequently, okay, your heap memory is continuously utilization is going like this direction, it's not coming down. Otherwise what happens that whenever you are applications are processing in your JVM heap size, so utilization should be like this one, zigzag. Whenever requests are coming, so requests are getting processed, when processed the heap size will be down. Again, when the request is processing, it will go high, and then when the request is not processing or the load is very low, it will come down. So this is the grab should be there for your heap size utilization. If it is going like this one, this is a problem. Your heap size is continuously getting increased, but it is not coming down. That means the cleaning is not happening properly, and you may get out of memory problem. Okay, sometimes we have a memory leak. That means the objects are created inside the heap size, but it not cleaned by the garbage collection due to some bad code or maybe some different symptoms. So if the objects are not getting clean from the heap size, this is called the memory leak. And we have to identify the reasons of the memory leak as well with the help of heap dump that we will cover in the next few sessions. Okay. So now hope it is very clear to you what is the garbage collection, different type of garbage collections, minor, major, what is the difference between them. Okay, what is the importance of garbage collection specifically in terms of tuning the heap size. Okay, so now I will show you with the execution how we can configure the GC settings in your WebSphere, then how we configure the GC logs, how it looks like, what exactly we look in the GC logs. So everything we are going to cover in the next session.